Hey everybody, it's Mr. Carr again. Today we're going to be looking at 5.5. We are going to be solving radical equations. And these are just some really cool equations, right? Or they're just equations that involve radical symbols. The biggest thing about this is we are just going to take whatever that index number is and do the opposite in terms of exponents. Like we undo this cube root of 3 by raising it to the third power. But we have to do that to both sides, just like any of our solving equations. So doing this will actually eliminate that. I'm going to do 2x plus 7 is equal to 3 to the third power, which is 27. And then I just solve my linear equation from here. So I got 2x is equal to 20, and I divide by 2, so I get x equals 10. With our radicals, especially when I look down here at the square root ones, it is important to double check your answers. Okay, so for example, here I want to do the cube root of 2 times 10 plus 7 is the cube root of 20 plus 7, which is the cube root of 27, which is a 3. And that's what I wanted over on this side. So this one checks out. We have a good answer here. On the next one, it's already, or sorry, it's cube root is equal to cube root. So I can just cube both sides. Doing that, I'm going to get negative 2x plus 9 is equal to a 2x minus 7. I can subtract 9 and subtract 2x. So that's gone and that's gone. So I get negative 4x is equal to a negative 16. And I divide by negative 4. So I get x equals a positive 4. Again, just do a quick double check. Is the cube root of 2 times 4 plus 9 equal to the cube root of 2 times 4 minus 7? Oops, sorry about that. Okay, so this is going to be the cube root of 8. Oh, sorry, that was a negative 2x. Sorry, that's a negative 8 plus 9 is a positive 1. Does that equal to the cube root of 8 minus 7, which is also 1? So we're good because 1 equals 1. All right, for the next one, we're going to go ahead and this case is the square root. So we are just going to square both sides at this level. So that becomes a negative x plus 3 equals 3x minus 13. From here, we can add our x's over and add 13 over. So that's gone. That's gone and that's gone. Yeah. Okay. So I get 16 is equal to 4x. And I divide by 4 and I get 4 equal to x. But you do want to keep checking this because if I plug it in, we get negative 4 plus 3. Does that equal to the square root of 3 times 4 minus 13? I get the square root of negative 1 equals the square root of negative 1, which is technically true. However, those are not real answers. These are not real. Since I can't actually plug 4 back into the original equation without getting an impossibility there, that means I'm going to just cross that off because it's extraneous. Okay, so that one does not actually work in the real problem, so we just get rid of it. The rest of our work with this is just the same thing. We're just going to undo our steps, solving out our equations. So for here, I like to look at this as P has a negative sign in front, then it's being added by 1013, then it's being square rooted, whoops, and then it's being multiplied by 6.3. So that means I need to undo the 6.3 through division. So 54.5 divided by 6.3 gives me 8.65 equals the square root of 1013 minus p. Then I'm going to square both sides here, and that gives me 74.82 equals 1013 minus p. From here, I'm going to subtract 1013, so I can undo that number. 1013. Okay, so I subtract those, I get a negative 938.18 equals a negative p, and then finally divide by a negative 1. So I get 938.18 equals p. Again, plug it back in just to double check. It'll work out in this case, but I just want to make sure you get that practice on that one. The other thing we're going to do today, they're technically radicals. They're just not written that way right away. If we have to deal with a rational exponent. So once x is isolated, we can think about what power could we raise to both sides. So we would just be left with an x. So let's start with this. Let's divide both sides by 4 to make that a little bit easier to work with. So x to the 3 halves is equal to, this will be 27 in this case. Okay, so a little more space there. So the idea is that I want to turn x to the 3/2 into just x. Well, that's x to the first power. Well, that's x to the first power, then I should be able to modify 3 over 2 by something. And what I'm going to do is I'm going to raise it to the the reciprocal of my exponent. 3/2 raised to the 2/3 power means it's going to be multiplying 3/2 times 2/3. That's going to give me x to the first power. But then I need to do the same thing here. So I'm going to raise this to the 2/3. So that's 27 to the 2/3 power. Well, we use our radical properties here. That's 27 to 2/3. So x is equal to the cube root of 27 squared. And I could do this in any order I want. So I'm going to do cube root first. That's going to give me 3 to the second power. So x is equal to 9. There's another one where it's a good idea to go plug it back into the original problem. I'm not going to do it in this case because it's good, but that's something to be aware of. Okay. Next one, same idea. Now, in this case, we want to be able to get this completely by itself. That way I can undo my radical. So before I do that, let's get rid of the -1. So that's going to be x plus 2 to the 3/4 equals 8. Draw that a little better. From here, same idea. We're going to raise, okay, give myself a little more space here. We're going to raise the left side here to the reciprocal, so 4/3. So that means 8 is also raised to the 4/3 power. Okay, I'm going to do it off to the side real quick. It's the cube root of 8. And I'm going to do that first and then raise it to the 4th power. So cube root of 8 is 2. And then 2 raised to the 4th power is 16. So that means this will actually just cancel out. So x plus 2 is equal to 16. And I simply just subtract 2 to both sides. So x equals 14. And that's it. Okay, so that's our idea with this one. Again, we're just trying to do like undo a reciprocal is the idea. This one, our final example here, is a little bit trickier. When we do this, we need to be careful. So first thing is, I want to undo square roots by squaring it, just like normal. But when I square the other side, this needs to be treated like this. It needs to be x plus 1 times x plus 1, which means I'm distributing it x squared plus 1x plus 1x plus 1. Combine these, I get x squared plus 2x plus 1. That's our idea there. Now, that's going to be this part. So that means x squared plus 2x plus 1 equals 7x plus 15. All right, now I can just do my normal rules. This is a quadratic now, meaning I'm going to subtract 15 to both sides. I want to make this equal to 0. So then I'm going to subtract 7x as well. So x squared minus 5x minus 14 equals 0. Factoring here. This one's actually factorable, so I'm going to go ahead and do that. 1 multiplies to -14 adds to a -5, x minus 7, x plus 2. So this one's going to turn into a +7. This one's going to turn into a -2. Now, because I have two answers, and especially because I have square roots, I need to double check both these answers. So I'm going to go back to the original problem. I'm going to do this twice. I'm going to do 7 and -2. So is 7 plus 1 equal to the square root of 7 times 7 plus 15? Okay, actually, let's move this over a little bit. Okay, I'll leave myself more space for the other one. So 7 plus 1 is 8. That'll be 49 plus 15. So if I add those together, I get the square root of 64. So I get 8 is equal to 8. That one checks out. For the other side, we got a -2. So -2 plus 1 equals the square root of 7 times -2 plus 15. -2 plus 1 is a -1. This is a -14 plus 15. Does -1 equal to the square root of 1? It does not, because -1 does not equal to 1 here. So this one is no good, meaning we have an extraneous solution. We can get rid of that one. So we only have one good answer, and that's x equals 7 in this case. Okay, so it's a good idea to always check your answers in the original problem, but always be careful whenever you deal with square roots, or even roots, I should say. So if you have a 4th root or a square root, that's always potential issues because it's an even root. Okay, but if it's an odd root, probably it's going to be okay, but it's still a good idea to check it just to be on the safe side. All right, and that is it for today. So remember, we're just trying to undo our operations. We undo square roots with squaring both sides. We undo cube roots with cubing both sides. Just trying to get stuff down to as low as it can go. We also can undo rational exponents by raising it to their reciprocal powers. All right, And that's it for today. So take care, everyone.